Hello and welcome back to another episode of From the Field. I'm your host, Casey Orr. I am a Wellington-based SA, that's Wellington, New Zealand, because there are lots of Wellingtons around the world, always have to clarify. And I actually forgot the intro had the gaming music towards the end. It's always a wonderful surprise and experience. We haven't actually used it in a little while. But yeah, it's absolutely freezing in New Zealand right now. Like I'm actually wearing shoes inside, which is probably kind of a weird concept for a lot of people. But yeah, other than that, we're going to be covering off in this stream around analytics, and it's something that I'm quite passionate about. I really, really enjoy talking about it. I talk with a lot of businesses and customers and all of that around analytics because it's very much sets apart businesses in terms of how they utilize their data and the insights they get from it. And the fun thing is on the technical side, like it's actually not a straightforward and easy process a lot of the time, but you're dealing with the inconsistencies of data. You're dealing with the fact that, like 2 years ago, you accidentally did a release and there's a whole bunch of nulls in your database now, and then that's fine. Generally, like when your day-to-day application, but as soon as you start doing analytics, it starts throwing a wobbly because it's like, why is this null? It shouldn't be null, and you're like, oh. Anyway, I'm getting a bit ahead of myself, but as everyone knows, there's a couple ways of doing it. Analytics is either the batch processing way or the streaming format. We are going to be leaning obviously more towards the streaming side of things and actually going quite deep into these technologies. With Nero here, Nero, do you actually want to introduce yourself and also give us your thoughts on when it is best to choose either a batch processing approach or a stream processing approach?
Yeah, thanks, Casey. So, hi everyone. My name's Nero. I am a senior solutions architect here at AWS, based in New Zealand, in Auckland, like Casey. So I'm in the better city there.
Oh, you want to start this Friday?
Hey man, it had to be said. But yeah, look, just like Casey, I find analytics an area that's an interest of mine, one I'm working towards having a lot of depth on. And so streaming analytics is always an interesting topic because it can be hard to implement. And sometimes it's looked over because of how hard it is to implement. But at the same time, it can be a costly thing to do. So you do want to pick your battles there. When to do streaming analytics and when to do batch. I'm a big fan of saying, what's the end outcome that you're trying to really achieve? Can you make use of low latency data to actually deliver a business outcome? Or are you doing it just because it's actually an interesting, cool architecture to implement? Nothing wrong with the latter, but keep in mind, what you need to go through to get there. The end result can be quite powerful.
Yep. And Hudi actually just said that they've never met anyone outside of Auckland, New Zealand, so they're convinced that that's a whole entire country. To be honest, a lot of New Zealanders think the exact same thing because they believe like over a third of our population is located in the Auckland area. I'm from Wellington, so you have, I guess, met me now. So you've met the one single person that exists outside of Auckland.
Come on, man. I was going to say there's a term out there, something akin to an orange that I won't use, but yeah, it is true. It is true. We are living in a little bit of a bubble, but I have got a chance to see the rest of New Zealand, unlike some, and I do think there's a lot more beautiful places out there. But come on, man, Wellington versus Auckland, it's an easy answer.
I'm just saying, like most of the country did celebrate when we had to quarantine the whole entire city off.
All right, let's not get into this one.
Yeah, as you can see, there is a rivalry even within New Zealand. There's the Australian-New Zealand rivalry, and then there's the Auckland versus the whole entire other country rivalry. All right, no, we got way off topic.
Right.
What are we covering in today's session, and what do we have to look forward to?
Cool. So I wanted to cover a little bit of streaming analytics, specifically from a technology point of view, how you can implement that using Apache Flink and Apache Hudi, an interesting combination. I wanted to start by kind of giving a little bit of a business challenge that you can relate that to. It's an abstracted version of something I've gone through. So we talked a little bit before about when would you choose to do it, right? And so hopefully this gives our viewers an idea of, okay, here are some indicators that streaming analytics might be useful here. So walk through that, walk into a little bit of a basic architecture. And I really wanted to dive deep into deploying Flink and Hudi, and showing some results, showing that latency, showing the data flowing through, and wrapping it up with things that went wrong. I want to be honest. I want to be truthful in terms of what it took for me to get there, and hopefully leave our viewers with something that they'd want to experiment with at the end.
It wouldn't be analytics without a few road bumps along the way. And I think at the end is a demo, right? So you're going to be walking through all of that through an interactive demo.
Yeah. I wanted to walk through EMR, how it's set up a little bit, and then dive into actually doing this in Flink and showing everyone the result.
Sweet. That sounds exciting.
Cool. Yeah. So let's dive into it. Hopefully your screen's coming up now.
I just wait until I can see the presentation. There we go. Behind the scenes magic. Boom.
All right. So building performant low latency streaming analytics, specifically using Flink and Hudi to do that. So like I said, I wanted to start by laying out a little bit of the challenge first. Let's put ourselves in the shoes of a retailer, right? A clothing retailer. Any company is our safe name, so we won't get in the way of anyone getting insulted. So any company is a large clothing retailer, and they've got an online e-commerce store, as with most companies these days, but they've also got many physical locations. That's really important to understand. This is a low margin, high volume business. So any passive events, things like staffing problems, or let's say stock not being there, or even system outages like the payment systems falling down, that can lead to a large potential sales loss, especially when it occurs during peak periods, right? So you think on Sundays when everyone goes to the hardware stores, or Thursday late night shopping, etc. So the challenge here is, how can we identify and react to some of those passive events and move to reduce those loss of sales? That's a big challenge, right? So I wanted to bring it back down to earth a little bit. So let's start with a simple step. If you work bottom up, all the things that can go wrong are going to reduce the number of sales you're taking in. So let's track the sales data in real time or near real time, and let's identify that problem from a bottom up perspective first, because then you can layer it with other angles, like where's the stock at, what are the staff doing, etc. I'm going to stop there. Does that make sense, Casey?
Yes, very much so. And it really comes down to, I guess we also want to qualify like how real time do these reports need to be? Like, are they going to be powering, or is it mechanisms that are going to react in real time, or is it going to be something that runs at the end of the day and then the actions are done the next morning?
Yeah, no, I think that's a great point. And so when I say first step, I want to start by being descriptive, right? We want to describe the problem. And if you think about a spectrum left to right of real time to near real time, right? On the left-hand side, you're going to see, a second or less. That's kind of like a proper transactional database type latency. On the right-hand side, you're going to get to all the way to batch, right? Overnight, once a day kind of thing. So the key here is, can we use Flink and Hudi to give something that is towards the left-hand side, but not quite where you have to start involving a large cost or high-performing kind of low latency systems. So going on, right? So let's imagine we've got these store transactions every time someone buys something. If we can stream that down through a pipe and perform some aggregates, what we can do is we can start looking at how much money are we taking in certain given windows, and we can compare that to yesterday, last week on the same day, or even last month on the same week, etc. And those trends can be an immediate indicator that there could be something else going on, like the delivery truck didn't bring in some of the more popular clothes, or the payment system went down and it hasn't propagated through whatever IT systems that they're using to notify the IT stuff that it needs to be fixed. So it's a passive way of understanding signals to begin with.
The marketing team loves it.
Well, yeah, I mean that's a very valid use case as well, right? Because what is becoming not even popular, it's almost you must, right? If you've got an e-commerce store, a lot of people will look up where to get something online and then go to the store because it says it has availability. Now, at peak times, you want to be able to send them to the right place. You want to be able to react. You want to be able to do things like put recommendations in front of the customer, knowing what's happening in the stores. So while not the end goal here, a very valid path that you would follow for it as well.
Yep. That bridging of the brick and mortar and e-com is a thing that businesses struggle with immensely for that reason, because you're trying to reconcile the two realities.
Yeah.
And people get really, really annoyed when online you say there's stock there. They drive all the way out to your store and then you're like, well, actually, no, you have to go to that other store.
Yeah, right. I mean, I do that. So
No, it has happened to me, and I will rightly say I was rather miffed.
And I wanted to have it generic enough because you can apply this to more than just retail. It could be food service, right? Chains that do high volume, low margin. Again, you don't want to be sending customers there if you don't have the thing they're looking for, etc. Or you ideally want to make sure they have the thing they're looking for before they get there, sort of thing.
Yep.
But look, let's flip that around, right? So the technical challenge, it is a little bit more straightforward if you look at it. We need to ingest high volume transactional data. We need to store and process that transactional data, but we need to do all of that with a lower latency. Again, going back to where in the spectrum do you want to sit? Real time being like less than a second sort of thing, or do you want to sit somewhere a little bit away from that, but still solve the problem that you're trying to do? Now, in our case, whether you understand what's going on to the second or whether you understand what's going on to, let's say, a 5-minute window, that's probably going to be okay, because what you're trying to react to really requires understanding a trend within a block of time. So near real time is really where we want to target here. Now, let's have a look at the architecture that I want to go through with everyone. All right. I've decided to use Kinesis here to do some data ingestion. Kinesis is fully managed. We've only got a single type of stream coming in here. So transactional data, whether it's from 100 stores or 50 stores, we want to know things like the amount, the type that was used to purchase it, FBOS credit card, etc., and what were the items in the store, right? So it's a single stream. We want to scale up and down as trends go up and down in the stores. So Kinesis really gives us a fully managed version that fits the bill here. I want to run Flink. So in this case, we're going to use EMR. Now, there's a number of ways that you can run Flink on AWS. You can use EMR, you can run it yourself in a container or something like that. You can actually use Kinesis Data Analytics, which is actually a fully managed version of Flink. Now, I've chosen to go with EMR here just because you get a little bit more flexibility in putting Hudi and all sorts of third-party libraries in, making it a little bit easier, but very valid options, the other ones. And then we want to use S3 storage with Apache Hudi, and we'll dive into this a little bit more. Grafana to visualize it, because we do want to be able to refresh quite often. And finally, Athena as a query layer that serves between Grafana and S3 and Hudi. Now, I want to dive deep into a few of these. The main focus today is Flink and Hudi, but can you stop there and see, does that make sense? What do you think, Casey?
Yeah, I got a few questions. Just I know that Kafka is all the rage right now. So, what would be your decision-making process over Kafka and Kinesis? Just
Yeah.
for your general enterprise.
No, look, that's a fair question, a common one too. If you've already got Kafka and your enterprise architectural direction is to use like a centralized Kafka instance, then great, use it, right? This decision is purely one of how can we get moving fast at the lowest cost, and cost being cost of maintaining as well. So if you've already got a team running Kafka, use Kafka. The decision I came to here was I needed a single stream that was taking in data. I didn't need multiple topics, which Kafka can give you. And I didn't want to mess around with setting it up, etc. So pretty easy if you've already got a direction there to use Kafka. If you're starting from scratch, consider Kinesis. It could make your life easier for this.
Yep, and I also see that you have Apache Hudi, which is one of probably the top four. You got Iceberg, Delta Lake, or Databricks, and I for the life of me can't remember the the last fourth one. But from memory, Hudi is the best suited for streaming data. Would that be a good understanding?
That's again another one like Kafka versus Kinesis, right? So I think Hudi has been around for longer in terms versus Iceberg anyway. If I remember correctly, Delta Lake was the first. Um, but it's about maturity, right? And if you look at the number of releases that have gone through and the number of people that are contributing to some of these open source projects, Hudi is still at the top of that. The others are catching up really fast. There are a number of features in terms of feature parity that Hudi does have that some of the others don't. And they are catching up. I might be out of date as well. So hold that thought. I wanted to go through those two things, Flink and Hudi, in a little bit more detail, and maybe understand my choice of Hudi. But Iceberg is a very valid one. Delta Lake is something I'm actually not familiar with, but could quite well work as long as it provides the functionality we need, which we can discuss shortly.
Yeah, in my personal experience, I found Delta Lake to be more user-friendly in terms of setting it up, just less powerful. That was like version ones, and I know they've iterated quite heavily since then. We do have a pretty good question that have come through from Husted, which is around rather than like just solely focusing on business applications, would it like have application for like gaming companies in terms of processing like player analytics, like real-time events?
Yeah, look, I think that's a very valid scenario. And in fact, we do have that scenario published somewhere where you can, for example, take a stream of events coming out of a table in a casino and start using it to identify trends, fraud, etc. A very valid case. So, yeah.
The amount of real-time analytics that goes into casinos is mind-boggling, by the way. If you ever want to go down a rabbit hole, I would highly suggest any of the viewers here to actually go down that rabbit hole. You learn a lot, and it's amazing what they can do.
Yeah, and that's a good example of when it pays to invest in it, right? Get to the most lowest latency because your return on investment can be quite high given the monetary value that goes through a casino in a short period of time. But yeah, so valid use case. But flicking back into this, we're trying to find a little bit of a middle ground, and the idea here is to show that well, typically to get really low latency, we use completely provisioned compute. We use a database that can give you that latency to store. But Hudi is challenging that. It's challenging that paradigm by providing the ability to ingest and aggregate data in a lower latency. So hopefully we'll see that at the end of this. Right, so dive into EMR a little bit, my choice there, right? So Elastic MapReduce, it's a fully managed platform that can run a number of open source big data frameworks. And in this case, not only can it run Spark, which it's more popular for amongst our customers, it can actually run Flink as well. And it comes pre-built with a connector for S3, so you can separate out provisioning, compute, and storage, right? So you're running your EMR cluster to size up the compute you'll need to run the Flink jobs, and you're using S3 as storage with the Hudi framework. It's managed, so you can set up auto scaling if you wanted to. And the really cool thing I really like about EMR is that you can use spot instances. Now, very quickly, if you look at a deployment pattern for EMR, there's a leader node, which typically is pretty much just a management node, right? It's running the resource manager, in this case, Yarn, and a coordinator. Your workloads actually end up running on either a core or a task instance. Now, cores can be added and removed gracefully, but typically you do want to have at least one running all the time because it does run HDFS, things that can be used for temporary storage and stuff like that. But what's really cool is for both the core and the task instances, you can decide to run that on spot. That can drastically reduce the amount of money that you spend on running a large cluster, mainly because within frameworks like Flink and Spark, they are fault tolerant. So if one of the task nodes goes down and comes back up, it can recover gracefully without intervention. Now, Flink, right? It's one of my favorite frameworks, and I personally think it's a little bit underestimated. It's still becoming popular, but it has some key features that are a little bit different to something like Spark. Mainly the fact that it's got stateful processing. A couple of other things before I dive into stateful processing. It's got some simple programming methods. So Flink allows you to write applications in Java, Scala, or Python. But if you're choosing to write an application, you can still use high-level abstracted APIs to just use like SQL statements to basically do all your work. And it's also got this SQL client and gateway, so you can just interface with Flink using pure SQL. And I think that can be a big advantage when you want to get some pipelines up and running really fast. The stateful processing of it should not be underestimated. So to put it into like layman's terms, if you're streaming in some data, let's just imagine a table with 100 rows. When that goes through Flink, Flink is holding the state of those records that went through. So it has the ability to save that for fault tolerance, and it has the ability to join sources from multiple streams. So well, not specifically for our use case today, for the gambling scenario that we talked about, for example, you could have events streaming in around what's happening in one table. You could have events streaming at what's happening, let's say at the cashier, the chip checkout, and you can start correlating things that are going on here to find, in this case, fraud, I suppose. So just using an example there, but read up on it. It's a big difference to some of the other big data frameworks. Now, Hudi. A lot of you may have heard of Hudi. It's an open source management framework. And the key thing that Hudi changed was it brought ACID compliance into a Hadoop-based file system. So before something like Hudi, we would have to deal with putting incremental data into HDFS or whatever. You would have to deal with deduping all of that stuff. But Hudi brings ACID, so you effectively get the transactional nature of a relational database stored completely just on Hadoop. So in this case, S3. Now, I wanted to dive a little bit into Hudi. Hudi's got three key components. It's got an index, it's got data files, and then it's got a timeline. There's a couple of important things here I want to dive into related to ingesting high volume transactions, right? So Hudi's got two storage types. If you've heard of it, copy on write and merge on read. Is that something you're kind of familiar with, Casey?
I would say that I'm not as familiar with it as I should be, but I know enough to be dangerous.
Yeah. Okay, that's cool. I wanted to spend a little bit of time kind of diving into this one, right? So copy on write. It's whether it's copy on write or merge on read, Hudi will end up using Parquet files. But the way copy on write works is important to understand. So let's look at a scenario, right? Let's say you've got your first transaction, T1 here, and you're inserting 100 megabytes of data. Now that's going to create a file, a Parquet file, in this diagram here that's shown as file slice T1, it's 100 meg. Let's say you insert T2, right? Now this is partitioned on, let's say, your store's transaction type. So anything that comes into transaction type, one's going to partition 1, another one's going to partition 2. So it's created another file that's 90 meg. Now let's say we updated some data from our rows that belong to that partition. What that's going to do when it's in copy on write mode, or CAL, is that's going to completely rewrite that 100 meg again. Now, if we did a 20 meg for another partition, for another file, it's going to go down there. If we insert 20 meg again, it's going to rewrite that again. So as you can see, every time data changes and copy on write, it's creating new files. What that does is it adds a little bit of latency to the write, but it takes the latency away from the read, because the reader just needs to read the latest file in each partition, in each file group. Now compare that with merge on read. We write 100 meg of data, creates that initial Parquet file, create another 90 meg of data, cool, that's another partition, creates another Parquet file. Now here's the difference, right? When we update some data in that original file group or slice, it's going to create a log file. So what it's doing is any deltas or changes that belong to that partition and file group, it's going to keep putting it into an append-only log. So that effectively takes the latency away from the incoming transactions being written. It's just going to go bang, 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 bang. And you see that. So and another transaction, but this is for a new file group. It goes in there. Another one. Now, at some point, it's going to go, okay, I need to compact these. And what's important to understand is if you see at the top right-hand corner there, Hudi's got a configuration you can set. And I believe the default for this out of the box is 5. For the sake of this example, we set it at 2, right? So in that file group at the top, there's been 2 commits. And so on that second commit, it's going to go, okay, I'm going to compact all of these and I'm just going to create a new file. I'm going to stop there because I get into this stuff, but I want to make sure I'm kind of getting the point across properly. Does that make sense to you, Casey?
Yes, it's actually probably one of the best explanations with the visual aid that I've ever seen. Because when I was first looking into it, it confused the heck out of me. So I kind of just learned the trade-offs rather than what was really happening under the hood.
Yeah. No, I find that interesting. And I think if you're getting into streaming into Hudi, it's an important one to understand, right? Because where do you want the latency to go? Where do you want to take the hit? Yeah, so in this case, I've chosen to go and use copy on write, and there's a reason for that. That's actually not related to what's the correct benefit, because you would think we're ingesting a large volume of transactions here, and the idea should be to get those in. But I ran into a problem, which I'll explain at the end. But yeah, know the difference. It's important.
And I also say that architecture is really about balancing the pros and cons, and like either at runtime or like at the design phase.
Yeah. Yeah, no, never perfect architecture. In this case, however, what works and what doesn't takes trump. But yeah.
I also find that perfect architectures tend to actually be worse in the long run, because just like an AI model, that can be over optimized to one particular problem. Like as soon as you try to make it more general or try to throw an edge case or expand upon it, and now that perfectness of that architecture or that model is actually now working against you, and that can cause quite a lot of headaches.
I think that's a very valid point. The other thing I've kind of been part of is trying to get to the perfect architecture can be quite time consuming as well, right? So you end up not getting to actually delivering a result.
Yep.
So that being said, that's how it works. I've chosen to go and use copy on write. So a little bit on EMR, a little bit on Flink, and a little bit on Hudi, diving deep there. I really just wanted to jump in and show everyone how this works. I'm just going to get out of the presentation. I want to make sure that the screen's coming through okay.
I'm gonna make that bigger and move it down. And I might remove myself, and I'll pop back up whenever I want to add something.
Sweet, that sounds good. So I'm looking at the EMR console on AWS, and what you can see is a cluster I've launched called Flink Hudi 2. Now I've chosen to install Hadoop, Hive, Pig, New, Spark, Flink, Trino. You don't need all of that stuff. The main things that you'll need is Hive and Flink. And in my case, I've launched a fairly large cluster, probably more so than we need. for the little things that we're doing, but I was playing around with this in terms of trying to understand task, core versus master. Now, when deploying this with Flink, a couple of things I wanted to point out. So what I'm going to do now is I'm going to connect to the master node. And when you're deploying Flink, what you need to do is you need to run a yarn session. Now, Flink comes pre-installed with something that does that for you. I've used this command here. It's doing a couple of things that are different to not running it. Specifically, I've done this because I want it to save its checkpoints to a specific bucket here. Now, there's a really good blog that someone's written up on AWS, which I'll link everyone to at the end. Explains a little bit more of this, but you got to start yarn, which is effectively the manager that runs the Flink runtime. The second part to this I just wanted to go through with everyone is when you're using EMR and Flink, you still need to do a couple of manual steps to make sure that you get the Flink Hudi library in. And this is typically on EMR, it will go into this folder. Now, I'm going to ask everyone just for a quick 10-second break. Sorry, team. I'm solo parenting today and I've got a sick kid. I just need to turn the TV show on for them. So, Casey, I'm going to put you on the spot to talk for 2 minutes while I do that.
Can you also remove the screen as well? There we go. Cool. Go sort your kid out. You know, at the end of the day, we do have to deal with the struggles of real life and the fact that kids do get sick more often than not, and then make you sick, which is always the fun part. So I guess it's a good point. If you do have any questions or any particular use cases that you want to explore, this is a great time to chuck them in, and then we can talk through them as we're going through this demo as well. And the other one is also if you have anything in particular that you're wanting to see in future sessions, then that would also be a good to put forward. But in general, I guess I'll go on about the here we go, sweet. They've been spared from my endless rambling.
Yeah, cool. I had to save everyone. I'm back. All right. Can you chuck my screen back on, please, Casey?
Yeah, wait until you've gone back into your browser.
Cool. Here we go.
There we go.
All right. So back to what I was saying. Sorry, team. So there's a couple of libraries that you need to sort out, and that typically lives in /lib, /flink, /lib again, actually. Interesting part. So if we look at what's in here, right, what you need to do is get in the right version of the Hudi Flink bundle jar in here. Now, you can read the doco. We provide that. That's already in the server. You simply need to either symbolic link it or copy it there. The other thing I've had to do to get what I want to do working here is effectively put in the Kinesis connector in here as well. And you can see that up here. So you get your libraries in here, if it's not already, and start the yarn Flink session afterwards. Once you've done that, you're ready to go. You can get an SQL client launched. So I'm going to move into the bin folder here. It gives you an interactive SQL client where you can just put SQL commands and it will submit that to the cluster to run. The other thing before we get started that's really good to get set up is finding your way into the Flink dashboard. Now, quickly for our viewers, how you do that through EMR. Again, this is documented, but what you do is you go into applications and you find the resource manager. Now, when you open up the resource manager, you can see the current Flink yarn session that I've run. This is the one that's running, and it gives you a link into the application master. Now, this is the link that you need to open, but be mindful, the link it actually gives you, if you look at it here, is the internal IP address within your VPC on AWS. So in this case, I've created a path to get from an external IP address in here. If you're running it in a secure VPC, you need to create some sort of proxy or tunnel into that. And if you change that to the actual IP and get connectivity in, you can get into this console. Now this console is important, so you'll see why in a second. Now I've got this, and I've got my SQL client here to submit jobs. So what I'm going to do to start with is I'm going to start creating some tables on Flink to start connecting to the source, which is a Kinesis stream. I'm not going to go through the setup of Kinesis and things like that today because it focuses on this. But I've basically got a Kinesis stream called Neuro Twitch Analytics 1. It's set up to auto scale, on demand, etc. Don't have to worry about it. It's just sitting here. Now, step one, we've got to create a new catalog, which is what you're seeing, create catalog command. Now, EMR can be configured to connect to the Glue table catalog if you've used that. So everything gets centralized on the Glue catalog system, but you still need to create an entry in here to reflect that. And I'm going to say use catalog. I'm going to create a new database that reflects a table that I'm going to create for Kinesis. And I'm going to say use that database. Now, this is the key part here. I'm going to run a create table command called transaction source. It's got transaction ID, amount, currency, payment method, probably a little bit unrealistic, but customer name and email, transaction time, and store ID. Now, when you're creating a table on Flink, you can say what connector are you going to use to create that table. So in my case, I've got Kinesis. If you were using Kafka, you could use the Kafka connector in a similar way. And then there are some parameters that are specific to the connector you're using. So in this case, for Kinesis, I've got my stream name, the region, the initial position. So I want it to just start from the latest position on Kinesis. I don't want it to go rewind back to any history, stuff I've tested. The format of data that I'm going to be putting into the Kinesis stream is JSON. So Flink is automatically going to flat map that JSON that comes through and convert it into a table for you. That's really powerful. I've set false to fail on missing field, just in case the JSON that you pump in is slightly wrong sometimes. Not that that should be the case. And then this one's an interesting one, which I'll dive into at the end, but it's effectively saying I want it to parse these timestamps in the ISO 8601 format. Now, when I run this, create that table, and then what I can do is I can go and type star from transaction source. Now, what this is doing is it's submitting a job to the cluster to say, I want to start pulling that Kinesis chart, Kinesis stream in real time, and it's converting that data into this tabular format that you can see. Now, I created a little sample data generator here. In Python, I've just got it basically creating a random JSON object with a transaction ID, amount, currency, etc., matching that table structure, and then just a while loop. And on my other tab here, I am just going to push in 10 transactions. See that JSON going through. Then over here, immediately Flink's pulled that out, converted it into table, and this is in real time. So the more you pump, the more that'll come out here. Now, we don't just want to keep looking at a Kinesis stream, right? What we want to do is going back to creating some SQL. Now, I want to put that into a Glue table. So I'm going to create a new catalog for Glue. I find this a little bit annoying, but you do have to create a catalog based on some of the connectors that you're using for, so that you can give it the parameters that it needs. Now, there might be a way to do this with just a generic catalog and then pass in those parameters per table. I haven't quite worked it out, but new catalog for my Hudi tables. I'm then going to create a database for my Hudi tables. And I'm going to create a table called transaction sync. Same schema as the source Kinesis. However, my connector is now Hudi. And I've got a couple of parameters here, write tasks for, which means it can parallelize and write 4 things at the same time. I've got an S3 path there for it. I've set it to copy on write, so COW, which is what we talked about before. I've set read streaming enabled, and that's really important for the next step, which I'll go through. And then there are some Hive sync settings here, which effectively means when Hudi creates this table, it will automatically update the catalog to match. So I'll run that. Go to the table. And then I'm simply going to do an SQL command here. This SQL command is insert into the transaction sync, select star from transaction source. Basic stuff, but really powerful, because what this is going to do is start a streaming insert job, and it's going to continuously stream what comes into that Kinesis table, which is the source, into the Hudi table, which is the sync in this case. Now, let's have a look at the Flink console, right? You can see now it's got this job running. If you go into this job, it gives you some great detail on what it's up to, right? So it's broken the job down into getting the job, this bucket assigner and stream writer, effectively showing you at a low level what Flink is going to go through as data streams through this. Now, if I go back to my data generator, and I could run this continuously, it's just easier to show in batches of streams, and run 10 more streams in there. And what you're going to see is that's going to start flowing through here. Now you can see there's 10 records that's been sent to the source, and then it's put 10 records into the next step, and it's so far done 6 records here, and now it's done 10. So it's flowed through this workflow here. And what we're going to find is if we go into this S3 bucket that I used before and refresh it. So here's my transactions sync table, right? And this is what it's done because I've got copy on write. It's gone and created 4 records because 4 files, sorry. Despite doing this 10 records in one batch, it's obviously processed them at different intervals. So copy on write, it's continuously created new files as the transactions have flown through. And just for clarity's sake, you can now query that Hudi table using any external system that supports Hudi, right? In this case, I'm going to Athena, and I can see those records in here. As you can see, those transactions have flowed through. So this is streaming directly into this Hudi table as records come in, and I can continue to just let that data generator go, and it'll just keep filling this table up. Now, I'm going to stop there for a second. Casey, I think this is amazing. I think just the fact that it's converted the JSON from Kinesis into a table, it's constantly streaming it just based on SQL. I think it's a really powerful, underestimated framework just to this point. But keen to hear your thoughts.
Well, being able to just even use other tools to query it just means that you can build a whole ecosystem around it. Not only are you getting the value from, that just streaming capability and the analytics that you can build from just Flink itself, but then you can actually go out and build the dashboards for the business and operations and actually start put it, was it dealing with the use cases down the road. So yeah, and this is why I love this type of analytics stuff. Like it's just this stuff gets me excited and way too excited.
Yeah, right. But I mean, getting something from source and putting it into sync, there's many ways you could do this, right? While the latency is pretty low, considering the target here is Hudi, it's a it's a file format based framework that doesn't require you to have a server running for a database, right? I think that is a key difference here. Like I could just as well put this into DynamoDB or something like that, but the latency here is pretty good compared to where it's going. But now,
and the cost would be significantly better because S3 is pretty much dirt cheap.
yeah, I mean, you still are paying for the constant compute for running the Flink cluster, right? But yes, you're not paying as much for the end target there. You're right, absolutely. So that being said, right, building on that a little bit more, kind of showing the features of Flink. Now, what you typically do once you get stuff into a database, data warehouse, whatever you want to call it, like this, a data lake, you want to start potentially building some pivoted views over the top, right? Aggregates and so forth. You don't want to have billions of rows of transactions, and then every time you want to see how much there was as a sum or something like that, run that over the top. Now, what's really cool is you can create a pivot table and have Hudi create a pipeline. So kinesis to the first Hudi table, from the first Hudi table to a second Hudi table that's holding an aggregate view, and it'll stream and update that constantly. So you're getting effectively what you would see in the data warehousing world as a materialized view done all in Hudi in low latency, near real time through Flink. So have a look at this, right? I'm going to create a table called transactions pivot. Now this is again a Hudi table. It's just got the same settings I used before, just 2 fields in this case. Okay. Create it. Now what I'm going to do is I'm going to run an insert into that pivot table where I'm going to select the store ID and sum of amounts from the other Hudi table. So if we go back to our cluster, now you can see 2 jobs running. And this is the insert into the pivot table, right? It's still initializing. So give it a second there. You know, when I was doing this, I got so scared when the red came up. I was like, damn it, something to solve, but it's actually just busy. Cool. So you can see it's initialized, some bytes received, etc. So now what I'm going to do is I am going to go back to my data generator and stream 100 records this time, right? Pumping through. Now let's follow that path, right? Let's go back to the initial job, the first one in the chain, which is going into the sync, right? Now you're going to see the records starting to increment up there. It's gone up to 80 now, and it should get to 110 or whatever at some point. Now, if I go back to the pivot table job, you can see the records have started to come through here as well. So it's got 110 records, which is the 10 I did earlier and the 100 I did after that. And so what you got now is, if I use Athena to query it, because it's a bit more visual, you've got that aggregate stored in a table for you already, right? So this has gone and said for each store, I've got my totals here. So it's doing that in near real time as the data comes through in an incremental chained pipeline, all just using Flink and Hudi. Now, again, I'm going to stop there. Does that make sense, Casey? I think that is an amazing, powerful way of building pretty much an incremental streaming lake house using all these terms that we do these days.
Yeah, I have done something very similar in the past, which is using this type of aggregation view for dealing with email events. So when you send out a campaign, you have the delivery messages coming through, the bounce messages coming through, people telling you that the web server doesn't exist, and all of this stuff. And then obviously you'll have some type of identifier to map it back to account, and then you can actually start displaying all of those statistics in real time and aggregating in real time, so you can actually then have them display on their dashboard. Because what we realize is that when someone runs a campaign and they don't see any numbers for an hour, that makes them really, really nervous. So having that ability to have that instant feedback is quite important. Like as humans, we want that instant feedback.
Nice. Yeah, no, pretty interesting. And I think it's a similar vein, right? You want to get that data pumping into dashboard. Look, I know we're going to run out of time soon, so I wanted to hurry this up. What I'm doing here is the last bit I wanted to cover is Flink can join static data and enrich your streaming events, right? So what I'm doing here, because I'm lazy, is I'm creating another Hudi table where I'm going to store stores details, right? So effectively, I'm getting a store ID in my transaction. This table is going to link that to the actual name of the store as an example. And I'm going to insert some data to show that static values. This could be stuff you stored in another database, which Flink grabs directly. It could just be a CSV file you stuck into S3. I've just used a Hudi table, and I've just inserted those 4 values as static data. And then what you can do is, in a similar vein to before, I can create my second pivot table here. In this one, I'm going to say store ID, store name, and total. And now I simply use an SQL to join across the static data and the streaming table. And I'm going to go up here and actually cancel my initial pivot job because we don't want that anymore.
Why we're actually waiting for this to come from heaven? It actually would in the future, I guess, when we have this amount of code snippets being done, we should actually really put this into a public GitHub that we can actually link.
I
So
agree.
the viewers can actually go through and do hands-on, because actually being hands-on through this is really quite important to understand. We'll get a firm understanding of the of how everything works.
Yeah,
So
no, I do agree. I think we should facilitate that, so hopefully they can then continue the journey, right?
yeah, and that's a great learning. Thank you for calling that out, Hartstead, in an indirect manner, because I got really confused when I first started learning this stuff. Like, it's really, really confused. You know how like the Pokemon game where it goes, it hurts itself in confusion? Yeah, that was me.
So just going to close this off, guys. So I've got my second pivot table here with my store name now, which came from that static data that was joined up. And what I can do is use something like Grafana, which you're seeing up here, and just using those tables, I can start pulling data in near real time, right? So as I refresh this, things change. For the most part. So the top 2 panels are linked to the pivot table, which takes a little bit longer in latency. The bottom left-hand panel is directly just on that transactional table. So you'll see that changing more often than the top 2. But remember that spectrum we talked about, right? Less than a second latency near that real-time area, all the way to like a day on the other side. Where do we sit? Using Hudi and Flink, we've got pretty low on that scale, with a price versus cost performance kind of position that probably will help most people start doing stuff with this. And that was it, team. I love feedback, love questions. We've got a few minutes, I think. Casey, what do you think?
I think it's awesome. I also just love Grafana in general. I don't know why. It's kind of like a crush that you have.
Well, I actually wanted to use QuickSight, if I'm being honest, just because, again, from a price performance perspective, we're not wanting to have it running all the time, pay for effectively a provision compute for a UI layer. But I think it is a lot easier to make the point with Grafana.
Yep. And because this is browser-based, it works on Windows, Mac, or Linux. It should. So do you want to cover that one off?
Sorry, you cut off there, Casey. What was the question?
So someone said, I guess because this is browser-based, it works on Windows, Mac, and Linux.
Yeah, if we're talking about Grafana, absolutely. So in this particular one, this is managed AWS Grafana. You run on AWS, and you can use any browser on your operating system to run it.
And if you are talking about interacting with like send those commands through to the underlying Flink, then that is just through command and command prompt in Windows or terminal in Linux and Mac, or
So
PowerShell in Windows.
Yeah. So Flink's got a number of ways you can interact with it. The first is you can code a job and just go into this web console here and say, submit a new job, right? The second is you can connect to this the server and get into that CLI that I just showed you guys, which allows you to run SQL. The third interesting one, which is getting a little bit more mature now, is Flink's got a remote SQL gateway. So you can run that on the server, and then from Windows, Linux, whatever you're at, you can connect to that server and push SQL commands in remotely. Currently, it allows you to use Hive too. So there's a program called DB Beaver, if you've heard of that, dbeaver. Those kind of tools can effectively act like your typical SQL client and connect to it and submit jobs. So a number of ways, depending on how you like to work.
So it's all the way through from much more developer focused to more of a hobbyist interaction type layer.
Yeah, I think for me, hobbyist interaction layer is that SQL client that I used.
Yep. Well, I wouldn't be surprised if a lot of people also, just go for that submit job tab you got there.
Yeah, I mean, it gives you that ability to use Git, have your code written down version. So if I was productionizing a job, I would probably go down that path.
Yeah, so this could very easily fit into your CI/CD pipeline that someone already has in place.
Yep, no, absolutely.
Cool. I will jump off on that. Then, I guess we'll sit around and see if anyone else has any questions to come up with. But in the meantime, I'm going to say, Nero, it has been an absolute pleasure having you on the stream. You're an absolute legend as always. And
And likewise, thank you for having me. It's always a pleasure to present here, and I'm looking forward to doing a few more analytics topics.
especially since your child is sick and having to manage this and that at the same time must be an absolute nightmare.
All good. I'm sure everyone knows how it is these days.
There's just a few things for admin. So I think you are doing another presentation in May, so in roughly a month's time, 5 weeks. So if you want to hear more about analytics and have Nero cover off that, then that's in about 5 weeks. Last week we did part 1 of how to become a network ninja. So if you are wanting to upskill into networking and get go from basics all the way through to much more advanced concepts, I'd highly recommend that you watch the From the Field video that was aired 7 days ago, because next week at this time we are going to be doing part 2, which is going to be talking about AWS network connectivity within AWS. So that will be the next step on the journey. I believe VODs are only available for 28 days or something like that. So that video won't be, able to be watched for probably another couple of weeks. But yeah, if you do really want to learn more about networking, and I would highly recommend it, because the cloud is making that much more of a important consideration for us technical folk and for architects in general, because it allows us to have many different layers of security that we have to actively be concerned about and make sure as devs we don't poke holes in it. And I got a fly in my room and it's attacking me. Cool. And that's with that. I hope everyone enjoys their day, night, morning, evening, wherever you are in the world. And with that, I will wish everyone goodbye. Thank you for listening, and Masiwa.
Thank you, team.
So good. And